Good afternoon, ladies and gentlemen, and welcome to the Avanade Innovation Center in Houston. I hope you've enjoyed the first day of the Future Digital Twins conference thus far and have had an opportunity to take in the wonderful panels, presentations, and breakouts we've had thus far today. To round out day one, for the next 25 minutes, I'd like to dive beyond the hype that still surrounds the digital twin concept and introduce to you a capability model that we've been working on that I believe can help you to accelerate the time to value on your digital twin journey. My name is Tor Schuler. I'm a Senior Director of Innovation here at our Avanade Houston office, and I work with many clients in oil and gas, utilities, and manufacturing to help them use innovative technologies and innovative approaches on their digital transformation journey. I'd like to start by taking a brief trip back in time and looking at some of the history around the digital twins. While it's commonly thought to be developed in 2002, digital twin technology itself actually had been a concept practiced since really the 60s. And it started with the first digital twin being created by NASA supporting the Apollo 13 mission. I have it behind me here on the screen, and this digital twin was entirely virtual. In fact, Gene Kranz, the flight director of Apollo 13, said that the only real things were the crew, the cockpit, and the mission control consoles. Everything else was generated by computers using models reflecting the physical world. Now, the availability of this digital twin to the ground crew became very, very important when things went wrong in space and new procedures had to be developed and tested before being sent up to space. You all probably seen the movie. It's fascinating. And I have a QR code here. There's a blog post by Siemens that goes into much more detail on what was done with this digital twin. I highly recommend it. Following Apollo 13, the next steps on the digital twin journey were the introduction of SCADA process control systems with the adoption of semiconductor technology in industry, which culminated in the 90s with connected SCADA and process spanning control rooms, where you had these large screens on the wall visualizing your entire process and allowing you to control this process from your consoles. Now, the first use of the term digital twin happened actually in 1998 in a documentary by Alan Alda, where a copy of his voice was referred to as his digital twin. The first time that the digital twin concept gained recognition as we understand it today was in 2002, after Michael Greaves gave a talk at the University of Michigan, and that culminated in a large-scale adoption of digital twin in 2017 as it appears on the hype cycle curves and becomes a strategic technology trend for many CIOs and CTOs. So what is a digital twin anyway? A digital twin is a virtual representation of real-world entities and processes synchronized at a specific frequency and fidelity that transforms business by accelerating holistic understanding, optimal decision-making, and effective actions, uses real-time and historical data to represent the past and present and simulate predicted futures, and is motivated by outcomes tailored to use cases, powered by integration, built on data, and guided by domain knowledge implemented in IT/OT systems. Now, this definition was introduced late last year by the Digital Twin Consortium. Its focus on outcome and tailoring towards use cases provides a perfect foundation to delve a little bit deeper behind what is required to start a digital twin journey, as we'll explore here later on in today's talk. Now, to understand some of the breadth of concepts that are related to the digital twin concept itself, I took some white papers and I ran them through a clustering algorithm and created a word cloud. I'm going to put it up here on the screen, and I'm going to leave it up for a few seconds for you to peruse, but I'm going to call out some of these concepts: products, digital threads, product design, supply chains, manufacturing process, virtual products. It's a variety of concepts that touch on digital twins. digital twins are becoming a strategic technology priority for many of my clients. In fact, Accenture, who, full disclosure, is Avanad's parent company, every year puts out its technology vision report. And for 2021, Accenture identified digital twins as one of the 5 key technology trends to watch. In fact, in a survey of Accenture clients, we found that 18% currently are using digital twin technologies and are scaling up the use of digital twins in their operations. And another 24% of respondents say that they are experimenting with digital twin technology, but are not yet fully in production. So certainly a lot of momentum behind this technology and an interesting time to be involved in the digital twin community. I put a QR code up there on the slide that links you to the 2021 Tech Vision. It's a fantastic read. Go have a look. So what are we going to cover for the rest of today? We're going to start with looking at the digital twin promise briefly, and then taking a different point of view on a digital twin, driven by the outcome and use case focus of the definition I introduced earlier, leading us to the introduction of the capability model I mentioned that we think can drive your digital twin journey. But before I do this, a quick word about Avanad. Avanad was created in 2000 as a joint venture between Microsoft and Accenture to bring to market Microsoft's deep technology stack with Accenture's unmatched subject matter expertise. And today, we have more than 40,000 skilled individuals across the world helping our clients every day on their digital transformation journeys, including, of course, digital twins. We are also a member of the Digital Twin Consortium. And if you have not heard of the consortium, go check them out, join them. It's a fantastic group of people interested in driving the conversation around digital twin, creating best practices, and creating clarity for everybody who wants to adopt and deploy a digital twin paradigm. Let's briefly visit the digital twin promise. When digital twins were initially adopted, they were championed for their ability to monitor, simulate, and streamline the data of discrete devices. The idea to optimize asset performance and reliability to predict and prevent asset issues before they occur. Now, recently, the scale of the models, the layering in of AI, and the increase in adoption have transformed the equation somewhat. We're now looking at optimizing productivity across entire production lines to simulate impact of changes before they happen in reality, and ultimately model and simulate entire value chains. We're starting to connect massive networks of intelligent twins, twins that are infused by machine learning and AI, linking many twins together to create living models of whole factories, product life cycles, supply chain ports, and even entire cities. These super twins creating unbroken threads of data, fabrics that will soon be essential to every enterprise's digital strategy. It's a grand concept, it's a great vision, but how do we get started on that road towards the mirrored world? What are the first steps that we can take today towards this vision? And I think in order to get there, we need to start looking at digital twins through a different lens, from a different point of view. Let me explain by going back to the definition that we looked at earlier in what is a digital twin anyway. And I want to focus on that last bullet point on that slide, that a digital twin is motivated by outcomes and tailored to use cases. It is those outcomes, those use cases that shape what our digital twin might look like, the capabilities that our digital twin has to possess to deliver those outcomes. So a digital twin I might create to forecast equipment failures of a pump might look totally different than a digital twin I create to forecast the carbon footprint of a facility. To turn this around, You could stipulate that the digital twin, in fact, is defined by the capabilities it needs to possess to achieve the desired outcomes. Now, we have a name for those capabilities. We call them digital threats. A digital threat is a certain critical capability that we need to develop to achieve a desired outcome. For example, if I wanted to better predict failure rates of my equipment, I might have to create capabilities to, number one, extract telemetry from that equipment. Number two, I might have to model that telemetry. Number three, I might have to apply machine learning on that data. All of these things, all of these capabilities are, in fact, digital threats. So twinning is becoming the journey of creating those capabilities. And the digital twin ultimately is the result that is emerging from the continuous evolution of those capabilities, those digital threats, created to achieve the desired outcomes that we want to pursue with our digital twin. It is not a static but an evolving representation of the physical entity, process, or resource that it models. And as the number of threats increase and as their strength increases, so does the completeness and fidelity of the digital twin representation itself. So you start defining your desired outcomes, you go and develop the capabilities, the threats that you need to deliver this outcome, and your digital twin emerges. And as you keep adding new desired outcomes, as you add additional threats to your fabric is becoming stronger, your twin is becoming more refined. Take a city as an analogy. Few cities are master planned from the ground up. Most cities emerge by people coming together, pursuing common goals and objectives. As those goals and objectives are being realized, services develop, complex relationships and transactions happen, and the city is starting to emerge. Now, how might we use this insight that a digital twin is in fact the evolution of capabilities that we're creating to shape our digital twin approach and strategy? Now, for this, we created the capability model, which can guide your journey along the digital twin road. Our capability model consists out of 8 capability groups, each in turn containing many digital threats or capabilities. There are too many of those to go into in detail here, but I want to introduce the individual capability groups over the next few minutes. The first capability group deals with the connected asset and adds capabilities around connecting a physical asset to a network to obtain telemetry of that asset, storing the digital form of the telemetry in a database or data lake, and last but not least, providing capabilities around physical asset monitoring, reports, and dashboards. The modeled connected asset is a capability group that adds capabilities around metadata modeling the asset, adding alerts, notifications based on defined rules, as well as operating on firmware, driver, software version management and updates. It also introduces the concept of reported and desired value capabilities that allows us to observe the reported state of an asset and define a desired state to have the asset operate from reported to desired state. The line twinning capability group adds recipe-based grouping of assets along production lines and provides capabilities around configuration and order of operations, line-level metrics, cycle time monitoring, and more capabilities around entire line twinning. Process twinning adds capabilities that deal with recipe, ladder logic-based digital representations of entire manufacturing or production processes. It adds capabilities that simulate production line configuration recipes, asset operating conditions, etc. This capability group also adds the concept of synthetic data, that is data that we create and use to fill in gaps along the production process where we don't have real telemetry data. Visualization is a capability group that adds capabilities around 2 or 3D engineering drawing support, blueprints or CAD-based visual representation of an asset. In this capability group, we also have capabilities that deal with overlaying of telemetry data, alerts, etc. on these digital engineering artifacts, as well as creating extended reality overlays of telemetry data and alerts onto the real world. Predictive capabilities is a capability group that gives us capabilities around behavioral modeling, physics modeling, predictive maintenance, anomaly detection, digital quality assurance, and automatic maintenance order creation, right on time scheduled maintenance, and more of those capabilities that deal with predictive analytics and mitigation. The self-learning digital twin capability group adds capabilities around machine learning and artificial intelligence that allows the digital twin to make automatic adjustment and updates to ensure optimal operating conditions and prevent problems before they occur without any human or operator intervention. And last but not least, the supply chain modeling capability group adds capabilities that deal with the supply chain modeling, including orders and pipelines, supplier inventory and supplier lead times, raw material inventories, manufacturing capacities and feedstocks, finished good inventories, and much, much more. The capability model is a very rich fabric of individual capabilities and threats, and we group them the way we did because, as you kind of can see by the name of these capability groups, each of these capability groups adds and requires different skills to create these capabilities, translating to different personnel requirements in the field as you develop and build out your capabilities. Let's take a look at how we might use this capability model. Let's assume we've identified an outcome that we want to create. The first thing we would do is we would go through our capability groups to identify the individual capabilities that we need to accommodate or achieve our outcome. And I have illustrated this here on the slide with these gray growing threads that you can see extruding out of the capability groups. This might be a little bit hard to see on the screen. I apologize for that. Now, you notice that we also have maturity lines going from low to high maturity across the vertical axis. What we can now do is we can ask ourselves, what maturity do we need for the individual capabilities to deliver on the outcome we desire? And maybe we get a distribution such as this. The next step would be to ask ourselves what maturity we actually have in these various capabilities and chart a path for us to close any gaps that we might have, either with skills development or by bringing in external capabilities. Now, as you can see, as we realize some of these capabilities, a fabric is starting to emerge. Now, if we add additional desired outcomes to the mix, we again translate those outcomes into capabilities that we need to create. Some of them we might now already have in our capability toolset. Others we may have to add new. And once again, we map the necessary maturity that we need for our capabilities and compare it with the capabilities we have in the organization. And again, either by our skills development or by bringing in outside capabilities, we can strengthen the fabric of capabilities that we now have in our model. And as we add additional outcomes and corresponding capabilities, you can see this fabric becoming more dense and stronger on the maturity scale, illustrating the growing completeness and fidelity of our emerging digital twin. Let's have a look at how this might work with a real example. And for this, I'm going to show you what we did for one of our manufacturing clients. We sat down with them and we mapped their value chain, here called the product journey. And it starts with concept ideation all the way through to the retirement of the product, the entire life cycle. And then we've worked with them to identify some of the low-hanging outcomes that we might want to attack immediately, but with the end in mind that we ultimately wanted to have capabilities crossing the entire value chain. So the first thing we attacked is the production optimization. And for this, we looked at the capabilities that we needed to create or leverage if they were already in place. I'm going to put up here a reference architecture for a digital twin. This one is based on Microsoft Azure services. And so I'm going to walk you through the capabilities that we created to achieve that objective, which was to identify dead times and anomalies that are happening along the production line. So we needed to get data from the PLCs that ran the individual pieces of equipment on the line. The client already had OPC UA in place, so we didn't have to create additional capabilities. We could just leverage that capability to get access to the PLC data. But we had to create capabilities in the connected asset capability group to ingest this data into the Azure environment. We did that via IoT Hub and IoT Edge, creating workloads that batched the data into Azure. We stored that data using a data lake. And the reason why we did this is for this particular outcome, we did not need real-time telemetry. We needed data to analyze with respect to inefficiencies in the overall line. So we put the data into cold storage, created that capability. And then in order to model the line, we needed to generate some modeled connected asset and line training capabilities, and we did that on top of the Microsoft Digital Twin services. Now, in order to create insights, we had to develop both machine learning and visualization capabilities. So we had to create some capabilities in the predictive space as well as in the visualization capability group. So altogether, we developed a number of capabilities, used some existing ones, and by doing so, we're able to create insights into these hidden inefficiencies along the line. Now then we asked the question, how might we add additional capabilities to achieve another outcome, and that is actually mitigate those inefficiencies, react to anomalies as we detect them. And so we added desired outcomes in that production control step of the value chain. And to do that, we had to step up our connected asset capabilities, because now we had to actually get real-time telemetry from the PLCs. We had to change our workloads, scale out the telemetry ingestion. We actually had to add some new capabilities around vision to combine with the data we got off the PLCs. And we had to create some additional capabilities in the predictive space to do hot and warm analysis. We also had to integrate with field support services to close the loop in the ticketing systems to dispatch an operator or an engineer to take a look at anomalies that we saw emerging based on the real-time data feed. Now, after we've done that, we've worked with the client to look at additional possibilities to improve the product lifecycle. And again, the same story applies. We identified the outcomes, we stepped up our capability development and our capabilities to achieve those outcomes. And so as you can see, over time, we created more and more capabilities, covered more and more of that product lifecycle. In this example, the capability model helped us to deliver value very rapidly by focusing only on developing the capabilities to the extent that we needed them, thereby de-risking the entire process. As we went through additional iterations, adding additional outcomes and thereby capabilities, a robust and high-fidelity digital twin emerged. And that is the power of the capability model. As you embark or continue on your digital twin journey, I would like to leave you with a couple of considerations for you to ponder. Is your business actually prepared for the mirrored world? Digital twins and the mirrored world are driven by data. Do you have the tools, the practices, and the data hygiene in place to make most use of your data? The data supply is the lifeblood of a digital twin. So do consider embedding sensors in physical products that you might be creating, spaces that you might be building or redesigning, and investing in solutions that deliver rapid ingestion and preparation of the data generated. Think about how digital twins can transform your innovation processes, how they can help you to start thinking about your entire end-to-end process differently, just like we looked at in the example earlier on. And last but not least, ask yourself how your enterprise will engage in the wider ecosystem of digital twins across your supply chain with your vendors, suppliers, and customers. Those kind of questions should drive your thinking about creating your digital twin strategy and journey. To close it out, I'd like to leave you with 3 key insights from the Technology Trends 2021 vision that you might be able to use to create buy-in for your digital twin strategy with your leadership. 65% of executives expect their organization's investment in intelligent digital twins to increase over the next 3 years. If your company is not one of those 65%, you are going to have to catch up or risk being left behind. Only 11% of executives estimate that 100% of the data provided through IoT devices or sensors in their organizations is fully utilized. So you're sitting on a goldmine of data that's just waiting to be exploited. The return of investment that you can get by leveraging that data is truly enormous. And 87% of executives agree that digital twins are becoming essential to their organization's ability to collaborate in strategic ecosystem partnerships. If your company is not one of those 87%, you risking being left behind, no matter whether you are an equipment manufacturer, an oilfield services company, or a producer. And with that, I want to thank you. I hope you enjoyed the last 25 minutes and were able to gain some insights. And I'm looking forward to engage with you in discussion around the capability model and its application. Feel free to reach out to me. I'm looking forward to hearing from you. Thank you very much and enjoy the rest of the conference.